Hello friends, today we are going to discuss questions of GS Geography, GS Paper 1, previous year's questions. Now, previous year one question was asked, that was, what is sea surface temperature rise? What is sea surface temperature rise? Second part was, how does it affect the formation of tropical tropical cyclones. तो फर्स्ट पार्ट इज व्हाट इज सी सरफेस टेम्परेचर राइज. वैसे तो ये क्वेश्चन अपने आप में ही थोड़ा सा अटपटा सा है. व्हाट इज सी सरफेस टेम्परेचर राइज? सी सरफेस टेम्परेचर राइज इज द राइज ऑफ टेम्परेचर ऑफ सरफेस लेयर ऑफ सी. आइडियली होना ये चाहिए था व्हाट कॉजेस सी सरफेस टेम्परेचर राइज. चलो क्या करें, यूपीएससी है मान लेते हैं. What is sea surface temperature rise? Right, sea surface temperature rise refers to rise in the temperature of surface layers of water. Now, in oceanic water can be divided into three layers. It is divided into three layers. Upper layer, that is warm circulating layer. Sea water is divided into three layers. The uppermost layer is known as epilymnion. Epilymnion. It is 100 meters thick, roughly 100 meter, or you can say 300 feet. Below it is thermocline, and bottom layer is hypolimnion. Now the upper layer, which is 100-meter thick, which is known as epilymnion, this refers to surface layer of water. Surface layer of water whose temperature corresponds to temperature of surface water. The temperature of this entire layer corresponds to temperature of surface water. And it is here in this epilymnion layer that effect of ocean current is visible. Below this is thermocline, where rapid decrease in temperature takes place. Thermocline. It is this rapid decrease is utilized in OTEC, conversion, ocean OTEC, ocean thermal energy conversion. और जो बॉटम की लेयर है, it accounts for 80 to 90% of sea water. This is cold uncirculating layer, static, cold uncirculating. It is static because of ocean current. It is the epilymnion where the water continues to move. Hypolimnion accounts for 80 to 90% of volume of water. It is cold uncirculating layer. अब तो what are the causes? Why does the sea surface temperature rises? Here the most important cause is burning of fossil fuels, which is leading to release of greenhouse gases in the atmosphere. These greenhouse gases have huge potential to absorb heat, and these greenhouse gases absorb heat. And 90% of these greenhouse gases, after absorbing heat, they are dissolved or absorbed by this surface water. जो greenhouse gases हम they are being released. These greenhouse gases, after absorbing heat, they become warm. They are dissolved in surface layer of water, and that is the most important reason for the rise of sea level as well as rise in the temperature of sea surface. Apart from it, the other causes for the temperature rise is melting of ice, because ice hoti hai, it reflects the solar radiation, but when the ice melt, more and more solar radiation is absorbed by the surface layer. So second reason is melting of ice. But this first reason, that is absorption of greenhouse gases, is the most important for the rise of sea surface temperature. Second is melting of ice, and apart from it, एल नीनो से भी वार्मिंग होती है सी सरफेस की. बट हियर इन द कॉन्टेक्स्ट ऑफ दिस क्वेश्चन, trade winds play a very important role. Trade winds, you might have seen that trade winds blow on either side of equator between trade wind belt. Within tropics, trade winds, northeast trade winds and southeast trade winds, while they are blowing over sea, suppose this is sea, while blowing over sea, they drag the warm surface water from the eastern part of the ocean to the western part of the ocean. मान लो यहाँ पर कोई एक continent है, this is one continent, this is another continent. What trade wind do? They drag the surface water from eastern part of the ocean to the western part of the ocean, from eastern part to western part. Therefore, in tropical regions, western part of the tropical seas are always much more warmer than eastern part of the tropical sea. Why? Because in tropics, warm surface water is dragged by these trade winds towards the western side of the ocean. So you see, western part of Pacific Ocean temperature is 10 to 12 degree higher than eastern part of Pacific Ocean. So western part of all tropical seas exhibit higher temperature because of trade wind. Now the question was, how does the sea surface rise in temperature affect the formation of tropical cyclone? Now, tropical cyclones are defined as heat engines that are energized by latent heat of condensation. That means whenever vapor condenses, it releases latent heat of condensation. That is the main triggering process for the formation of tropical cyclone. They are asking what is the sea surface temperature, what is sea surface temperature rise, how does it affect the formation of tropical cyclone. Tropical cyclones always get formed over those seas where the surface temperature of the sea is 27 to 28 degree centigrade. 27 to 28 27 to 28 degree centigrade, where the sea surface temperature is high, because in this case adjoining layer of air over the sea are full of vapor. This air is full of vapor. Tropical cyclone, as a rule of thumb, always get formed over those seas where the sea surface temperature is 27 to 28 degree centigrade. Because of why? Because of this, the adjoining layer of air above the sea, this air is warm and moist. It is having huge amount of vapor content. So sea surface temperature rise, how, the question was, how does it affect the formation of tropical cyclone? Now they are not formed anywhere. Basically the sea surface temperature should be sufficiently high. This happens in trade wind belt, in the western part of tropical seas, where the trade winds drag the warm surface water. In every ocean, tropical cyclones always get formed on the western part of tropical seas. Reason is because it is here that the trade winds drag the warm surface water on the western side. Because of warm water, adjoining layer of air is full of vapor. It is full of vapor. Formation of tropical cyclone, बताया ना, tropical cyclones are what? Heat engines. The technical definition, they are heat engines which are energized by latent heat of condensation. Now, what is latent heat of condensation? See, when water is heated, this water is heated, it absorbs heat. After absorbing heat, it transforms into vapor. Water, when heated, it transforms into vapor. Now, when water changes into vapor, it changes its state from liquid to gaseous state. To change the state, water is at 100 degree centigrade, वेपर इज एट 100 डिग्री सेंटीग्रेड. लेकिन अगर तुम्हें वेपर से मैं जलाऊं तो तुमको बहुत जल्द मचेगी, गर्मी ज़्यादा लगेगी. वाई? व्हेन वाटर changes its state or phase from liquid state to gas state, some additional heat is required to bring about this change. That additional heat is known as latent heat of vaporization, and this heat is trapped within the vapor. हवा में जो vapors होते हैं ना, these vapors are the result of heating of this water, and when this water heats up and transforms into vapor, for the change of state of from water to gaseous state, some extra heat is required, which is trapped in this vapor, and that is known as latent heat of vaporization. And when these vapor condense back to water, when it condense back to water, liquid state, this latent heat of vaporization is released in the form of latent heat of condensation. Now, tropical cyclones are heat engines which are energized by latent heat of condensation. It is this latent heat of vaporization that is preserved in these vapor. When these vapors will rise, they will condense, they will release latent heat of condensation. This latent heat of condensation. And this latent, when the vapor will condense into water droplets, they will release latent heat of condensation, and this latent heat of condensation is added to this rising parcel of air. Same vapor. जैसे कोई vapor, when the vapor rises, it expands because of decreasing atmospheric pressure. It expands and cools. As a result, the temperature of the rising air decreases. As the temperature of the rising air decreases, its moisture holding capacity also decreases. As a result of which, vapor starts converting into droplets of water, because air कर तो expand रही है, but because of its cooling, when the air cools, its moisture holding capacity decreases. As a result, it cannot hold so much moisture, so some moisture converts into water, and when this vapor converts into water, it releases latent heat of condensation. This latent heat of condensation is again added to this rising parcel. Why? Because air is bad conductor of heat. It cannot go anywhere. जो latent heat release की थी, it is added back to the rising parcel. As a result, the rate of cooling decreases, but it makes the air more buoyant, more lighter because of this warming, which causes the air to continue to rise. तो जहां भी वार्म सी सरफेस टेम्परेचर होगा, adjoining layer will be full of moisture, warm, they will have huge moisture, and when this air will rise, it will condense and release latent heat of condensation, and that latent heat of condensation will be added to the rising parcel of air, which further pushes the air upward, keeps it lighter, it pushes the air upward, and this continuous pushing of air creates low pressure on the surface, and this low pressure induces convergence on the surface, and cyclonic activity comes into existence. Tropical cyclone comes into existence, and so far so long this tropical cyclone remains over warm seas, and the air, adjoining air, is full of moisture. It, on rising, it continues to condense. When it rises, air cools. Because of cooling, its moisture holding capacity decreases, so moisture condenses into water, and when moisture condenses into water, it releases latent heat. The latent heat released is added back to the rising parcel of air, which causes the air parcel to further rise, and this continuous rise creates a low pressure on the surface, which induces convergence of air on the surface, and tropical cyclone comes into existence. Tropical cyclones can form over only warm tropical seas. They can survive only over warm tropical seas. As soon as they make a landfall, they become weak, because on land, air is not having vapor. So basically what will happen, when this air with less vapor will rise, the vapor will condense. Since vapor is less, so less condensation will take place, less latent heat will be released, and less latent heat will be added, so it will rise, less buoyancy will be there, so air will rise slowly. And on land, when when there is no moisture, there is no condensation, no release of latent heat, no heat is added, and so air stops rising. When air stops rising, this low pressure converts into high pressure, and the convergence of air stops, and tropical cyclone dies out. It is a simple way for GS purpose. I think you might have got uh, clear. So that was the discussion.